Started. All right, so our warm up. Notice how the logo is gone. That's exciting. Oops, I didn't mean to do that. I meant to do that. Let's go ahead and break these down and solve these. So we got two problems that right now we're going to learn more about parent functions on Friday. So we're just going to focus on these two right now just to keep it easy. These two functions are two basic family functions that have problems in their domains. So let's go take a look at this. So with the square root, right, square root of x, right, x has to be greater than or equal to 0, all right? So that's just a note that we need to know. So what I'm looking for here for the domain, I need to know that 1 minus x squared has to be greater than or equal to 0, right? So basically another way, like this is just a fancy way of saying x, the input can't be negative, right? So, have a lot of people who are late. All right, so what we're gonna do here is we're gonna go ahead and solve. So to solve here, I'm gonna subtract 1 from both sides. Okay, and then, oh my gosh, people are late. Gotta stop being late, guys. And then I'm going to get negative x squared is greater than or equal to negative 1. Now remember, when we're multiplying or dividing by negatives, that's where we're going to have an issue. So we're going to go ahead and, my other class asked me a great question here. Why do we flip the inequality sign? A way to teach you this without actually teaching you is think of negative as opposite. So we're thinking of the opposite of x squared is greater than negative 1. Well, if I get rid of that negative, then it's the opposite of opposite, right? So this is saying the opposite of this is greater than this. So if we get rid of the opposite, right, then we got to change the sign, okay? Because this was saying the opposite of x squared was greater than this, but now that we have x squared, that's not the opposite, so it's going to be less than, right? So that's why you flip the sign. You can think of the negative as being opposite. So this says the opposite is greater. Well, now we don't have the opposite, so it's not greater. It's less than. So we're not done yet, though. We still have the x squared. Going to square root both sides, but it's quite silly because now we lose an answer here, right? So we're going to have x is less. We're going to have plus or minus. Excuse me. So how do we do plus or minus? Well, you're going to have x squared is less than or equal to 1, right? And then since it's, so you're going to have, right? So if we had x squared equals 1, x equals plus or minus 1. So then x is going to have to be greater than or equal to negative 1. Okay? And you can just think of this logically, right? So this can't be, if so, it's going to be less than 1, right? So negative 1 squared is 1, right? So if you have negative 1/2, that's less than 1, right? So negative 1/2 squared, right? That's still going to be less than 1. But if you went above this, if you went lower than this, like negative 2 squared, right, would be 4, and that's not less than 1. So you have to think of this, when we're doing this, think of in terms of absolute value, right? The distance from 0. All this is saying when we're doing this is that the distance from 0 has to be 1. So that's how you would write it in interval notation, but we want to write our answer in, this is inequality notation. We want to write our answer in interval notation. So I'm going to write my answer like this, right? Saying that, so again, the underline here, saying that it can equal, so we're going to be going from negative 1 to 1. So that's how you do that. This was a really interesting problem because of the negatives and then because of the square root with there and getting the plus or minus 1. Okay? And remember, right, the reason why this is happening is x squared, right, is symmetric. Okay? So when you take, when you're taking the square root of that, the square root only does this, so we have to take both sides of the value. Okay, and so that's just the symmetry plane part. All right, next one, we have h. So we have to remember with rational functions, you can't divide by 0. Oops. Okay, So you can't divide by 0 there. So that's our general rule. So let's see if this pen works. Oh, it does. Lovely. What do I want to do here? So if x can't equal 0, right, and that's you can't divide by 0. Okay, so you can't divide by 0. So then what we know then is that x squared minus 4 cannot equal 0. So again, this is understanding parent and family functions. We're going to do a little bit of more of this next time. At the end of class, at the end of the day today, I'm going to post a new document in Google Classroom that's a review of all the parent functions. So it's going to have all the asymptotes and domain and range restrictions. So we're going to go over that on Friday, but there's no reason not to get started on that early. Okay, so we're going to go ahead and solve this. And notice how algebra, right, the golden rules of algebra still work. Doesn't matter if we change that. And then here, we're also going to lose an answer because there's actually going to be two things, right? It's going to be x equals a positive 4. Oops. 2 or x equals negative 2, right? Because negative 2 squared equals 4 and positive 2 squared equals 4. Okay, it's the same thing here. I should have done that here, right? The square root of x is less than 1, and then go like that. So when you have that, you really are having x is less than or equal to 1, or x is greater than or equal to negative 1. Again, the negative switching the equal sign, the values there. Okay, so the domain here, so we know it can't equal 2 and it can't equal negative 2. So just go like that. So to write this as interval notation, this is the only time that interval notation really kind of sucks, is when you would then go like this. So negative infinity to negative 2, and then negative 2 to 2, and then 2 to okay, and the reason also why we're doing this, guys, is that you're going to be dealing with some piecewises, and being able to graph a piecewise, this is what's more helpful. Okay? Even though you're right with set notation, you would just be able to say x, this is the set of all reals except x equals 2 and x equals negative 2. Okay. All right, so no one has said anything except for Graham, which was the original comment on noise. So I hope you guys are doing okay with these. These obviously were a little bit more difficult, which is why I chose them for the warm-up, just because I want you guys being exposed to, right, the square roots, what happens if you have a negative with an inequality, it flips the sign, right, and then again with the square root of a square having two answers. Okay. So if no one has any questions, I'm going to get started in 1.5. So I just got a question. Is the infinity with the positive 2, isn't that a positive? Yeah, this is a positive infinity because it's going to be going on forever to the right. Yeah. So remember, this is domain. I should have said that. Right, we're going to get into range today. So with the range, you're going to get funky things with this, right? Because as this gets infinitely bigger, right, the output's going to go to 0, right? So we got to be really careful with that because the range is going to do something different, right? So with rational functions, as this gets infinitely big, right, you're basically just creating a division of an infinitely big number, so you're going to get closer and closer to 0, or infinitely close to 0. Yeah, I'm glad that you asked the question. You know, the only bad question is the question you don't ask. Ting ting, I should trademark that. All right. So we're doing 1.5 today. So again, we had an extra day, so today's going to be nice, chill, and slow. Which for third period, not all the time is it's nice and slow, but we're going to have nice and slow here. So 1.5, we really focused on domain on our last 1.4 homework, and today we're really going to focus on range. So this is going to be looking at output of functions. Am I focused in on here? Ooh, that's a little bit bigger. Okay, so we're going to be looking at the output of functions. Yep, bye-bye. So I'm going to, so first thing I want to do is talk about, so when we talk about output, when we talk about what works for the output, we talk about range. Okay. Now with this, it's really important, and we talked about this, well, maybe not in this class. So here, I don't have, I'm still working out this technology. So I'm going to see if this works. I want to see if I can draw. So as you can see here, range, oh, that's so cool. I'm drawing on the book. So range here, right, is our up and down. So now the book does this weird thing where if it doesn't draw a point, it doesn't draw arrows. But this one, see, has a solid point, which means that my domain ends here. So if I was looking at domain, oh, this is awful. Okay, so domain here, it looks like I go from -1, which it can equal. Oh, this is not bad. And then I go to, it looks like 5. Now notice how 5 is an open, so that's going to be a parenthesis, okay? And then if I wanted, yeah, right? And then if I wanted to do range, now remember, in interval notation, we always start with the lowest. So the lowest here is -3, and it can equal. And then the highest here is +3, okay? And it can equal that as well. So I'd go boom, 3. Okay? So there is an example of looking at a graph and being able to find domain and range, okay? And as you go further in math, you're going to have to be able to do this algebraically. And we're going to introduce this a little bit in pre-calc, but in calculus, it's going to become a really important thing. So let's see now if I can get rid of all of it. Neat. All right, cool. Yeah, oh gosh, it's a book. What do we do? You guys are funny. All right. Let's keep going back to our notes. So range, just taking a look at that, you have to be able to, it's really important. In fact, mostly calculus is how do we do all of that analytically with calculus. But what you need to know right now is, can you find just the basics of it, so when you get to calculus, then you understand, like, okay, I know what I'm talking about with range and stuff. And also with some functions, there's some special range restrictions that we need to know as well. Here, I'm going to have you guys try one because we have time. Okay, I want you guys to ignore this bottom part. Can you guys find the domain and range for this function? So can you just assume that it ends at the bottom? So go ahead and find domain and range there. I didn't start a timer, did I? And then we're assuming that it just ends at these dots, because or else this is a dumb problem. When you guys are done finding the domain and range in participants, can you give me a yes or a thumbs up? Okay, so that was a good solid minute, and there's only 4 of you who said that you are done. Let's just go over this really quickly, because hopefully, if you're rusty at this now, we need to get to a point where you can just look at this and automatically have it. So remember, domain is going to be my input. So my input here is left to right. So I want to find the most left point that it can be, and I'm seeing -3 right here. And then it's an open circle, so I'm going to have parentheses. Okay. And then I'm seeing the most right point, and that's +3. Okay, and it's a closed circle, so I'm going to do a bracket. Okay, so that's what I have for my domain. And then up top, I want my lowest point. So you look here, so -6, it actually can't equal -6 here. But over here, it can equal -6. So can it actually equal -6? Yes, it can. Okay. And then, sorry, that looks like a B. Can't undo it. Oh, gosh. Okay, writing with the mouse is hard. And then that's a 6. And then the highest it can be is 3, and it can equal that. And so that's all we were going for there. Okay? Does anybody have any questions about that? Here, I'm going to see if I can. Yeah, what's up? Yeah, so when you're doing the range, you just are looking for the lowest possible output. And the lowest possible output here, since here it would actually be like -5.999999999, but here the lowest possible would be -6. So it's infinitely lower. Infinite, like it's, like the difference is infinitely small, but it's just that infinitesimally fraction smaller. So you'd take that -6. Yeah, that's a great question. I'm so glad you asked. Okay, how's everybody else doing? All right, so I'm going to turn that off and get rid of this book. Ooh. Jokes. And then let's go back. Here we are. That's always exciting to see. All right, so we are going to get back to business. Here, I can zoom in just a little bit. All right, so that's a little example of range, right? So it's just like domain, and make sure with range, that's when we start getting into the open circle. Oops, how does that look in my camera? Open circle, and closed circle. Okay, I can't do it with the camera. So yeah. So next we're going to talk about, so that's that. So next we're going to talk about the vertical line test. And the vertical line test is basically, is it a function? Now, some of you might be looking at this and be like, Kraft, I know what the vertical line test is. Well, students always get confused between a vertical line test and the horizontal line test. So it's really important that you understand each of them individually and what they do, because they're different and they do different things. So the vertical line test is it a function test? Okay. So a vertical line test, all it's testing for is for every input, there is only one output. Okay. So the focus on here is the input. Okay, so for every input, there is only one output. The horizontal test is going to be for every input and output, there's only one input and output, and that's called one-to-one. So this is not that. This is the vertical line test. Let's do a couple examples of this. So, okay, there. So I have a polynomial of some sort. Of course, I did a screwy bit there, but you guys need to see that. You'll see it exactly. But basically, the idea is, imagine that I have a scanner. What a cool generation you guys are. And this line just scans, goes like this, goes like that. And basically what it's looking for is that every input, there's only one output, right? So even in this dirty bit that I drew, right, there should only be one output. Okay, so basically, if you do this, okay, then this would be a function. This turns out to be a special point in calculus, so that's kind of fun that I did that. All right, I like to call it a fake shake. Fake shakes happen in some. The most famous one is cotangent fake shake, or arctangent, I should say. All right, and then another example is a circle. Okay, so if I do my little laser thing, so right here, you might be like, hey, this point works, right? But then as you go across, you see that there's 2 points, and that doesn't work, right? So is a circle a function? No, a circle is not a function. And you're going to be like, Kraft, what are you talking about? You gave us an equation for a circle. You're right, it's an equation, not a function. Okay? If I wanted it to be a function, I would have to solve for an output, solve for y, right? So just really quickly, I'm only doing this because we have time, and when you have time, you can do actual fun stuff with math, right? If I wanted to solve for y, I would get y equals plus or minus the square root of r squared minus x squared. And notice how this isn't a function, right? It's actually two functions. It's the top half and the bottom. Okay. So cool, when you have time, you can really do stuff. So as you can see, a circle is not a function, though we can approximate it as two different functions, which is why you need a piecewise. Oh, yeah, chicka, what? All right. So I'm having a good time. Someone asked a question today. That's really good. Okay. Next, what's up? Okay. So what we're going to be talking about next is finding zeros. So when we're finding zeros of a function, this is so part 1.5 is all about output, right? So zeros, when we say zeros, or sometimes they're called solutions or x-intercepts. Okay, basically this happens, right? So this is when y equals 0, right? So when the output is 0. And if you've taken physics or you're in physics or going into calculus, you learn that like the coordinate system is totally up to you. So what we usually do is we pick our coordinate system so that y equals 0 makes things nice, right? And the further you get in math, you realize that like you control math, you can do whatever you want with it. And math teachers might lie to you a little bit saying that you have to do it this way, but you can do it any way you want. And so this is really important because we usually set up our axes so that the important bits are at 0, because then it just makes math so easy. You can use zero product property. Okay, so really quickly, I ran out of room, so I'm going to flip this over. I'm going to go ahead and I'm going to, I have time because we're out at 9:50. I'm going to go ahead and show you really quickly 3 different functions, how to find zeros. So the first one, 3x squared plus x minus 10. Okay, so we're going to find zeros. Okay. So to do this, you're going to have to remember how to factor. Okay, because we want to get this, when you have zeros, zero product property, or I like to call it the ZPP, is going to be your friend. So if you don't remember how to do this, there's a bunch of different ways to know how to do this, but the easiest way to do it that I've seen so far, and most visual, is you go like this. So, and then what we're looking at here is we want a product and a sum, okay? And your product is going to be, why I'm sorry, I'm not thinking clearly right now, and I need to take a step. So the product and the sum, so the sum is negative 10, and then the product is negative 30 squared. And I'm pretty sure I'm doing that right. It's been a while. I didn't really prep for this. So I'm looking for 2 numbers that add to negative 10 and multiply the negative 30. What do we got, guys? Is this doable? Did I pick one that's not doable? So what do we got for negative 30? We got 3 times 10. We got 5, 10, 15, 20, 25, 30. 5 times 6. Oh, shit. I just swore. Oops. All right. So maybe this method isn't super good. It should have factored out a 3. Here, let's do that. Guys, why am I'm brain farting super hard right now? Why am I brain farting super hard? I'm just, for the sake of time, let's go to the next one. I'm brain farting super hard. I know how to do this, and I know the answer, but I'm brain farting. I'm going to come back to it, because it's going to come back to me in just a second. Okay, so let's go ahead and do this one. Okay, so this one's really easy, like beyond easy. To solve this, you're just going to square both sides. You don't lose an answer, so you don't need to do anything, right? So if you square root only has positives. Subtract 10. You get negative x squared divided by negative 1. You get 10 equals x squared, square root. So this is where you lose an answer. So right here, you don't lose an answer. Okay, here you lose an answer. Okay, so if you square a square root, don't lose an answer because the square root's only positive. Okay, and then here, you're going to square root this, you are going to lose an answer. So your answer is going to end up being plus or minus 10 equals x. Okay, so when you lose an answer, you have to add in plus or minus. Okay, so that was a really good one to do there. Okay, next up, let's do another one. So in this one, okay, so I want to find the 0 or the root. Try to put little curlies on my T's. Okay, so for this one, so a couple of things to remember, because students always get really confused about this, is that what makes this 0? So we have to remember, with a rational function, you can't divide by 0. So the bottom can't possibly make it 0. And if you don't, so when I look at these, I've done these so many times that I just flat out ignore the bottom. Now, some of you probably aren't going to be there yet. So if you don't remember that, just remember the first step into solving this would to be multiply both sides by the denominator. And then what's anything times 0? 0. And then you get to that same thing just being like, hey, in a rational function, if you want the output to be 0, it's never going to be the bottom, because the bottom can't be 0, right? And that's part of the zero product property, right? Because remember, division is actually just multiplication. You're just multiplying fractions. So if the only way to get to 0 is if you have 0, and you can't divide by 0, so this term can't be 0. So really only the top can give you an output of 0, which is a cool lesson. You should that's something you should be thinking about. So I'm going to go ahead and add 3. And I'm going to get 3 equals 2t divided by 2. And I get 3 halves equals t. And remember, guys, fractions are your friends. Fractions just means that you were too lazy to actually do the division. And here, like, cool, it's 1.5. No. Yeah, 1.5. But who cares? Just leave it like that. Because, see, I had to think a whole bunch, and then I had to double check myself. Okay? So fractions are your friend. Lazy is cool. Okay? How are we doing for time? I got 9:33. Okay, I'm going to come back to that quadratic factoring problem just a little bit. Okay, because we have more important things to go on. So two big things that we want to think about here is, boom, okay, make sure with square roots and squares, you have to figure out, when do I lose an answer, when do I not lose an answer, when do I lose an answer, and then with this one, make sure with rational functions, if you're trying to find an output of 0, the bottom isn't going to do it for you. Okay? So next up, I want to talk about increasing, decreasing. So I always see, so I taught AP Calc the last 5 or 6 years. And with students always mess this up because they forget that English is also really important, and Spanish as well, or in fact most languages except for Japanese, and there's a couple others. But remember that we read left to right. Okay, and it's always shocking to me is how many people they come to calculus and they start reading right to left. And this is what I mean by this. So if I have a quadratic, okay, what students will say is they'll start at the vertex because it's eye-catching and it's pretty important, and they'll be like, well, look, at the vertex, after the vertex, I'm increasing, right? Because I look at my output and I'm going up. All right, good. And then they'll be like, but look, if I go this way, I'm also increasing. See, so what did I just do there? I was reading right to left. you always, yeah, right? No, it happens. So you always have to read left to right. So if I'm going here, notice how from left to right, my output is going down. I'm decreasing. Okay? And then from here to here, I'm increasing. So if I was going to use interval notation, if this was just x squared, then I'm decreasing from negative infinity to 0. Now, I'm not going to include 0 in AP Calc. Some people might include 0, but it's a critical point, so it's not increasing or decreasing. You don't need to know that right now. And then increasing, I'm going to go from 0 to infinity. Okay. So that's what we're going there. Okay, so always read it from left to right. Okay, don't go the other way. The definition of increasing, decreasing is the output. So as you go from left to right, the output goes up or down. So up would be increasing, down would be decreasing. Now you're like, if I told you that this is like a huge part of calculus, you might be like, well, calculus doesn't seem so hard. And you're right, it isn't. It's just that then we start talking about slope, acceleration, and jerk, and all of that stuff. And then it gets confusing because it's like, what are we looking at? Are we looking at the rate of change? Are we looking at the area under the curve? So make sure that you understand increasing, decreasing, because it gets more complicated when you start adding in different parts of that. Okay. Now, part of increasing, decreasing is max and mins. Okay. So with max and min, sorry, these are abbreviations. With max and mins, I always like to tell the story. So here, if we go like this. All right, I'm gonna go like this. Okay, so here's my graph. Way too many humps. I got excited about the humps, right? It's all about my mathy humps. And so if we have this function, and I'm just going to go ahead, so this is a closed circle. This is a closed circle. And maybe I'll do this for a reference. Okay, so there are two types of maxes and mins. So in the dangerous world we live in, there are multiple ways to name these. Your book uses relative and absolute. Which is also a alcohol, so make sure you're careful when you're telling your parents what you learned about today. So relative and absolute max and min. So I should be careful. So you can have relative maxes, absolute maxes, but just so people are on the same page here, what's going on, there's also some people call it local and global. Okay, so in some books and internet. Okay, so local and relative are the same, absolute and global are the same. Your book uses relative and absolute, so I'm going to go ahead and use relative and absolute. So the way that I like to teach relative and absolute is this. So starting with the highest point, let's call this Mount Vernon. Okay, and that would be a absolute max. Okay, now you look at this next hump, and it's obviously lower, right? So let's call that Burlington Edison. Okay, we'd call this a relative okay? Because it's relatively a max, because here you have Cedro-Woolley, which is a relative minimum. Now, you're like, Kraft, Cedro-Woolley, like, come on, those guys are a relative min? Well, then you have to forget that over here you have concrete, which is a absolute minimum. Do I have any people, anyone here from concrete? Absolute minimum, okay. And then, you know, you might have another relative here. You might have alger, which is a relative. Right? Now, I say relative minimum because we're looking at this whole picture. If I was just looking at this domain, then alger would be a relative maximum, wouldn't it? Okay? And then I'm going to put, what's another? I don't want to put Conway. Conway's pretty sweet. How about Anacortes? Is it Anacortes High School? I don't know. Okay, and then here, why don't we put Conway? Now, a couple of things I really want to point out. Do you guys see how not only I did peaks, right? And these are going to learn in calculus are called critical points, but I also check the endpoints. So I'm going to put that here. You should always check endpoints. Check endpoints if you have them. Right? And if we're talking about Skagit Valley, right, we have endpoints because Skagit Valley ends. Okay? So, so with that, that's basically max and min. You have to check your endpoints. You're just looking for max and mins. Again, this is just a review, and it's just a recapping of what you guys, I think, already know. Okay? All right, cool. So it's 9:43. I do want to go back to that problem, and I want to solve that problem with you because I can't go to bed at night thinking that I can't do a math problem. That's a true story, actually. I often go to bed with a notebook next to my bed, so if I have a dream about the problem, I actually solve a lot of problems in my dreams. That I can go ahead and do that. All right, so let's go back to this problem because no problem is going to defeat me. Well, maybe it can defeat me, but temporarily. I will always find a way to solve it. Okay, so there's a lot of different ways that we can factor this. So I tried using the box method, but I'm going to be real, I haven't used the box method in so long that I forget how to do it with an A term. So, but I do know that if I have this, I know one of my terms is going to have a 3x in it. So that's one way of doing it. Okay, and this has an x. So, so if I look at this, right, because I have 3x times x, that gives me my 3x squared term. Okay, so that's why I know if I just do that, if I have 3x and x, I get my 3x squared term. Now, the trick here is that I need to get two things that add to 1, right? So they're going to add to 1, and they're going to multiply to 10. But the tricky part here is 3x times something, and then this number times something has to give me a difference of 1. So the first thing I'm going to start with is, what do I get to multiply to 10? So what do I get to multiply to 10? That's 2 and 5, right? Okay, so if I have 2 and 10 here, and hey guys, I'm doing this, I don't know if you were taught this way. This is how I was taught to do these problems, because the box to me is just, it's so slow. So again, all I'm doing is I'm just going here. So 3x times x is 3x squared. So I get that out. And then I'm looking at this last term. So I know 2 times 5 is 10. So now what I want to do is there some way I can put these together? So I don't want 3 times 5. That's going to be too big. So I'm going to go with the smaller one. So I'm going to try, oh, and it's negative. So one of these has to be negative. Well, I'm going to try, we have to get to positive x. So 3 times 2 is 6. And then that's a difference of 1. So I'm going to go 3 plus 2. So if I do that, then I'm going to get a plus 6x. And then if I do a minus 5 here, then when I distribute that, I get a minus 5x. And then when I go negative 5 times 2, I get a negative 10. So let's double check how I did. So I got a negative 10, good. And then if I combine these two, okay, so this right here is factored form. So does anybody have questions about that? We have time. So I did this without the box. I haven't done the box in a long time. I don't usually teach the box because it's so slow. Are you guys okay with this, how I did this? Are you okay with how I explained it? So again, if I'm recapping, I mean, I can do this again and go a little bit slower if people want. Do people want me to go slower? The only thing that's next, right, after I did all of that, then I just go like this. Okay. So we're going to try this again, but we're going to go slower. It's hard, guys, because no one's really interacting with me. I don't know how fast I'm going or what's going. So I want to get this, if I want to solve this, right? So I want to solve this. I have to get it into factored form, right? So to get this into factored form, what I'm going to do, I know that it's a quadratic, so I'm going to have two factors, right? And then when I'm looking at this, I look at this first term. I know I have to get 3x squared, so I'm going to have 3x and x, right? That's the easiest way. So like you might be like, why did I do that? Well, that's the easiest way to get 3x squared, right? I know I need to have an x here. I know I need to have an x here. 3x times x is the easiest way to get to 3x squared because 3 is prime, right? So I'm not going to have two numbers. Now, if 3 wasn't prime, then I would have an issue, right? Because then I could have other possibilities that would work. But because 3 is prime, the only thing that multiplies is 3 and 1, okay? So are we, again, if you guys aren't good with something I say, just say stop right away, okay? So I start with this term, 3 is prime, so I know only 3 and 1. Then the next thing I'm going to look at is here. I know that these two numbers have to multiply to get negative 10. Okay? So that's, again, this is just like the box problem, right? Except I'm not wasting my time drawing a box. So these two numbers are negative 10. So I think, okay, what multiplies to negative 10? I have 2 times negative 5 equals negative 10, and I have negative 2 times 5 equals negative 10. Okay? So those are the two. So this is going to be either positive 2, negative 2, positive 5, or negative 5. So now the next thing I have to figure out is this. Okay. Well, I'm going to have two terms that add up to this, right? So to get those two terms, it's going to be this term times this term, right? That's going to be my first x. And then this term times this term. That's going to be my second x, right? Because these are only two x's. So 3 times something plus something times x is going to give me this. Now, I know the numbers have to be 2 and 5 and plus or minus them. So now it's just a matter of figuring out, okay, 3 times what plus the other one, which one gives me 1? So what I need is, I need my positive number to be the biggest, don't I? Okay, so if I go 3 times 2, I get 6. If I go 3 times 5, I get 15. Okay, 6 and 5, the difference is 1. So that's what I'm looking for. I'm looking for a difference. You see right here, the difference, because we're adding, so the difference is 1. So 3 times 2 is 6. That gives me a difference of 1. So again, I'm not using a formula to do this. I'm just thinking through it. I'm just using logic, okay? Because if all you do is memorize a formula, you'll never get to this point where you can just think about it. If you understand it, then you can be like me and be like, oh crap, I forgot how to do it. So in finishing this up, so I know that 3 times a positive 2 is going to give me 6. And then to get negative 10, this has to be negative 5. And then you always double check your work. So if I go like this, I get 3x squared. If I go like this, I get 6x. If I go like this, I get negative 5x. And if I go like this, I get negative 10. Now, notice how I got this. Sometimes you try it and it doesn't work, and so you go back and you make adjustments. But the beauty of this is I don't memorize a formula, right? I don't use my brain space to do that. I know it's 9:50, guys. Just let me finish this up, and then we'll take off. Okay, so to do this, then I use the zero product property, or as I like to call it, the ZPP, okay, zero product property. And that says that if you have two things multiplying to 0, one or both of them have to be 0. So I would go 3x minus 5 equals 0, or x plus 2 equals 0. And then I add 5, get 3x equals 5 thirds. Oops, sorry, 5 divided by 3, I get x equals 5 thirds. And then I subtract 2. I get x equals -2. Okay, so these would be my two solutions. Okay, as always, guys, if you have questions, today is Tuesday, so my office hours are from 1 to 3:15. You guys can stop on by. Thanks, guys, for staying a little bit over to get through that.